Hey, welcome.
Hi there.
Yeah, so our next guest speaker will give us talk about using artificial intelligence to investigate organized fraud rings. Please allow me to welcome Mr. Debanjan Chatterjee. He is the head of decision science at Bureau.id, where he builds AI-driven products to counter fraud. His past roles were with HSBC and Amex. He has more than 16 years worth of expertise in data science, designing solutions to mitigate fraud risk across a plethora of financial products for global market. Debanjan articles on fraud detection have been published on Nasdaq too, Association of Certified Fraud Examiner, Analytic Magazine, and Bitcoin Magazine. Over to you, Mr. Debanjan.
Thank you. Thank you. Thanks so much for the introduction. So, hi everyone. This is Debanjan over here, and I've spent more than 16 years in the field of counter fraud analytics. And other than fraud, I've also built analytic solutions for a wide variety of financial crimes like money laundering, terror financing, human trafficking, and drug trafficking. And today I'm going to speak about a specific topic which I feel has been traditionally missing from the list of priorities of financial organizations in their journey to combat fraud. And that is the topic of how can we use AI to have a better understanding of organized fraud rings. Uh, so basically, I'll start with. I hope my presentation is visible. So I'll start with how big a problem organized crime is, and I'm sure all of you are aware that over the years there's been a sharp growth in the severity of organized crime, across the globe. And this diagram that you're seeing on your screen, this sort of shows us how stolen payment data, as in credit card data or debit card data, is used in a variety of transnational crimes throughout the world. So what this means is sometimes what happens in the spectrum of financial crime is that the starting crime is fraud. However, the spoils of the fraud are then used by a wide variety of organized rings to fuel other kinds of crime. So, for example, as you can see in this diagram, you have other crimes like money laundering, you have human trafficking, you have drug trafficking, and so on and so forth. So, what this means for us is that if you are able to do a better job collectively in countering fraud, then the world automatically becomes a safer place to live in because it sort of cuts off the funding from the other kinds of financial crime. Moving on, I'm sure all of you have heard about the dark net or the deep web, which is basically the internet that we are aware of, where all the sites are hosted. That is basically referred to as the surface web, and that part of the internet that is not indexed, that is not sort of accessible by search engines, that is known as the dark net or the deep web. And there are a lot of the darknet by itself is a thriving ecosystem. It's an e-commerce ecosystem, you can call it that, because there are a variety of merchants over there who sell a whole variety of illegal products. So if someone wants to commit fraud, he or she can log into the dark net and then buy buy information around stolen credit cards. There are also other kinds of similarly other kinds of crimes like buying drugs and so on and so forth. So the graph that you're seeing on your screen, this sort of tells us about the growth in the importance of the darknet markets. So the orange bars that you see, that is the revenue, the growth in revenue. There are all these e-commerce merchants that are housed on the darknet, how their revenue has been growing over time. And then the amber curve that you're seeing over there, that gives you an idea of the number of transactions, the number of transactions where funds have been routed to the darknet. So the darknet by itself is another way of us sort of trying to grasp the reality of organized crime, because the way this particular ecosystem functions is that organized crime rings employ hackers, and those hackers would be involved in data breaches at retail stores, at healthcare providers, and so on and so forth. And they would try to siphon off personal information like credit card information or information related to your identity. And then what they would do is they would upload that information onto the dark web, where it is free for anyone and everyone to purchase. And then aspiring fraudsters, if I can call them that, uh, typically they purchase, these data from these e-commerce merchants, and then they to proceed on with their fraudulent activities. Uh, this slide talks about the fraud shops, specifically, the fraud shops. So, as I earlier mentioned, there are a wide variety of um, content that is sort of available on the dark net, catering to different kinds of crime. This one is basic. So you have shops that sell fraudulent information, as an information about stolen cards, and then also you have shops that sell drugs and so on and so forth. So the yellow bars that you see on your screen, though, that is the revenue in millions of US dollars for the year of 2020. And as you can see, there are quite a few. For example, Empire Market is one such e-commerce shop on the dark web that sells, fraudulent cards and so on and so forth. So the basic gist of this graph is that selling information on about fraudulent cards, or conducting a data breach at some, let's say, e-commerce giant, and then selling off that information on the dark web is big business, and it brings big money for the criminals who are involved in this kind of business. The last part of the story where I'm trying to explain the gravity of organized crime is, of course, the impact of the ongoing pandemic. And according to research by the United Nations, what we've seen is, because of the pandemic, a whole lot of businesses obviously, they've started to struggle, and organized crime rings often reach out to these struggling businesses, and they try to sort of move them over to the dark side. And what happens in this kind of a modus operandi is that the lure of easy cash, especially given in the background of the pandemic, sort of spurs some of these struggling businesses to lend their infrastructure to organized criminals, with the ultimate result that fraud sort of moves on to a different level altogether. Now, even though we all of us are aware that organized fraud rings are something that have been growing in strength and in size in the recent past, when you sort of try to map this to the way financial organizations conduct their fraud investigation, be it analytics or even be it operations, you would see that there's a lot of emphasis on monitoring of transactions. So, for example, if your firm issues credit cards or debit cards, then as an analytics professional, your job might be to sort of scan through, write codes that scan through millions and millions of payment card transactions, trying to find out outliers, trying to find out segments with high fraud rates, and accordingly build rules or machine learning models which would tell the system to approve or decline on a real time basis any card transaction that's coming in. So that's sort of the bread and butter of the counter fraud analytics fraternity. The other bit that counter fraud analytics is involved in is, of course, verification of consumer identities, wherein there's a lot of focus and there are a lot of algos that are written to to sort of ascertain whether the consumer is actually the person he or she is claiming to be. So you have know your customer kind of initiatives. You have a lot of firms who've started using biometrics such as iris scan, or your thumb impression, and so on and so forth. um, and then but what is missing from the current state of counter fraud analytics is a dedicated effort to sort of understand organized crime rings. And this is basically what's going to be my rest of the presentation is about. So how do we actually go about understanding or dissecting organized crime rings in the world of fraud. Now, one way to do it is to basically, so there are a bunch of ways to go about this. One way is, what I'm referring to here as access intelligence, wherein we need to find out how the fraudster is accessing the platform. So let's say if you're working for a bank or if you're working for a fintech, and you have this app. So obviously, you would have data pertaining to the login information. I'm assuming you would have device intelligence also that will tell you that, the make of the device, the operating system, and so on and so forth. And also, you might be having a bunch of features that are related to the network that criminals are using. For example, let's say you can you can decipher from the data whether a bunch of people are using the same Wi-Fi. You can do device clustering to find out. Let's say, if I am logged on to your banking app and then some other person is also logged into, you can find out whether my device and the other person's device are geographically close to one another. So these kind of analysis can sort of guide you towards understanding as to whether there's a coordinated effort that's running somewhere in conducting fraud, on your organization, or whether is it the fact that most of the trends that you are seeing as a part of the fraud team, most of the trends are sporadic in nature. So that might be the first step. The second step, which is actually much more significant and interesting, is tracking money flows. So, for example, if you're working in fintech, or even, I mean, this would be relevant for any financial sector. So obviously, you would have data pertaining to, let's say, consumer A is paying consumer B, consumer B is sort of buying something at merchant X, and so on and so forth. So if you're able to trace out the money flows, that might give you an idea of of the entire network, as in who's connected to whom and how that network looks, whether it's a closed network, whether it's an open network. If your analysis tells you that that network is not making much sense, what that would mean is probably there's no coordinated effort, there's no organized crime ring problem that your organization is facing. Maybe most of the fraud trends that you are dealing with are sporadic and scattered fraud trends. Sorry. The other bit might be profiling of locations. So again, you would have data that would tell you that the location from which the login information is coming. So you can obviously conduct a risk profiling of locations. There might be certain fraud rings who are based in certain geographies in your country, or across countries, across international locations, and you might be able to sort of map the fraud attacks that are coming in to specific locations. So the next time you see a suspicious login attempt from the same location, I mean from a risky location, you might want to do something about it. And last but not the least is, it makes sense to sort of maintain a directory, a historical directory of all the fraud attacks that your organization has faced, so that you can find out signature patterns in fraud attacks. So what this means is, like, if there is a organized ring A vis-a-vis an organized ring B, in all likelihood, the kinds of threat vectors that you would see in your data would differ significantly across different crime rings. And the reason for that might be that different crime rings might be focused on different kinds of fraud. Some crime rings might be focused on fraud and terror financing, or fraud and money laundering, and so on and so forth. Then again, some crime rings might be like very nascent rings, so maybe they are not that sophisticated, and most of their fraud attacks get detected by the financial organizations, and so on and so forth. So if you are able to build a directory of various kind of signatures in the fraud attacks that you faced, uh, down the road, when you come across a nascent trend, you would be able to map the signature that's there on your file, with the fresh trends that you're seeing. And this slide sort of talks about the various kinds of org structures, if I can call it that. I mean, since these are organized crimes, crime rings, what happens is they are run like a proper organization with a proper org structure. So you might be having a senior person who's sort of recruiting, let's say, money mules, right? Or hackers or other kinds of professional criminals. So if you are able to sort of uh, um, you know analyze in detail, let's say the money flows, or let's say how many accounts are logging in from a single device, or how many devices are mapped to a single account, and so on and so forth. You might be able to map out the network as I was earlier alluding to. And there might be different kinds of networks, that might crop up. One is, of course, I mean, there are hundreds of, if you do a deep dive into the field of network topology, you would come across like hundreds of different kinds of structures that networks typically have. Here I've just, sort of, here I've just for the sake of demonstration, I've put in 4 or 5 different kinds of networks. So let's say, the star network. How do you interpret if you find a star network in your money flows, let's say? So what this means is this is a kind of a hub and spoke model for a crime ring. You have a central person, and then you have other people. So let's say if you find that the people at the periphery, or the devices at the periphery, they are sending money to one single device, what that might mean is there is a single leader who's leading, that fraud ring. So it's a pretty hierarchical organization. And from a law enforcement perspective, if you're able to take down the leader, the crime ring might get automatically disbanded, which is not the case for this ring kind of a structure, wherein obviously there's no clear hierarchy and everyone seems to have equal power. In a ring kind of a money flow, basically, you would see person A transferring money to person B. So it's a circular kind of a structure. These kind of structures often crop up in analysis for anti-money laundering, because let's say person A is trying to sort of launder money, but obviously person A would want his or her funds to be returned to him or her at the end of the laundering process. So you would have this kind of a circular money flow. Similarly, you have mesh, you have buzz, you have tree, and so on and so forth. It can be a combination of all of these kinds of topologies. You might come across certain kinds of network structures which really are, maybe 2 or 3 edges and a bunch of nodes, not much connected to one another. Let's say a linear kind of a structure. What that would mean is that probably that's not an organization. Probably it might be a coincidence, or it might be a bunch of random people, who are just trying to game the system. Now, once we sort of, so if I do a recap, the first step in this kind of an analysis would be to understand there's a whether the fraud attacks that my organization is facing, whether it's a work of an organized ring, or is it the fact that these are sporadic attacks. Now, in case if I see that, by using let's say my clustering algorithms and other sorts of algorithms, if I come to the conclusion that this might be the work of an organized ring, then basically I move on to step 2, wherein I try to reduce the structure, to get some better clarity on how the ring actually looks visually. And then the third bit would be what you're seeing on your screen right now, which is once you've identified, broadly that, there are these various um, disjoint rings that might be contributing to fraud vectors, we can create a bunch of metrics to understand these rings even better. So, for example, we can find out the stability of the org structure. So, what I mean by that is, let's say you are doing a time series analysis, and let's say 2 years back you found a ring where it was, let's say a star system, but now in more recent data you've seen that it has morphed into a ring system, right? So maybe something is going on with the leadership of that fraud ring, or there might be maybe law enforcement has started impacting that ring, right? So you can find out the stability of work structures, you can find out the agility of operations. So what this means is everyone who's been a part of fraud analytics understands that, detecting fraud is like a cat and mouse game. So the analyst would deploy solutions, and then the fraudster would react to that solution. So basically what happens is the analytics professional studies the data that he or she has at his or her disposal, builds a bunch of algorithms, and then it gets deployed. The fraudster then tries to maneuver around that solution, because obviously, the fraudster would try to game the system. So, for example, if you have deployed a rule which says that, if a credit card transaction is more than $1,000 at a jewelry store, then I would be declining that. But the fraudster would do it. The fraudster might try a high value transaction at a different kind of a merchant, which is not a jewelry store, so that he or she gets approved. Or the fraudster might try a lower dollar, transaction whilst remaining at a jewelry store. So this is how the fraudster would try to game the system. Now the thing is, different kinds of fraud rings might differ as far as their agility is concerned. Like some fraud rings might be resourceful, they might be intelligent enough to find loopholes in your system, whereas some fraud rings might be like too naive, or maybe they are too nascent and they might give up easily, right? So you might be able to create metrics that tell you how nimble or how resourceful a particular fraud ring is. Then, of course, the last but not the least is the growth in business. So basically, the kind of when I say business, I mean the business of crime that these fraud rings are a part of. So you can find, if the fraud ring is expanding over geography. So maybe in old historical data, you found that this fraud ring is sort of focused on a specific area. So maybe all the victims reside in a particular city, let's say, and you now find that people in multiple cities are being targeted. So that would mean that this is an ambitious fraud ring who's sort of trying to increase its ambit. Similarly, you can do the similar kind of analysis by studying crime typologies. So again, as I was mentioning, if you see that a particular crime ring was focused only on specific kinds of fraud, but now is sort of also moving on to different kinds of fraud or to different kinds of financial crime, again it would mean that this particular crime ring is sort of looking to expand its ambit. Similarly, devices like creating fake IDs is, of course, it's a low cost kind of step for any criminal, but acquiring lots of devices is something that is relatively costly. So let's say if you've zeroed in on a particular fraud ring, and if you found that, let's say, that ring sort of uses X number of devices, and then someday you see that the number has sort of exploded to 2x, that again would mean that the fraud ring is investing into acquiring more assets, which again is a signal that it's expanding its ambit. Then of course you have victim demographics. So again, you might see that certain fraud rings target, let's say, upwardly mobile people in certain urban locations, right? Or let's say they target victims in specific parts of the cities, or people who are in specific kinds of cities, let's say, or in specific countries, let's say, internationally. And if you see that that the demographic spectrum of victims is sort of increasing, or if it's changing, that again might mean that the fraud ring is, the fraud ring is sort of changing its priorities, or the fraud ring again is trying to expand its ambit. Benefits of the approach, I think this is the last slide that I have. Yeah, benefits of the approach. So again, just to recap, in my 16-year journey, I haven't come across too many organizations where analysis pivot around fraud rings. Typically, analysis pivot around consumer IDs, trying to verify those IDs, and then of course, analytics in general. You have a whole lot of algorithms that are written where people trying to find patterns in transaction data. But this kind of an approach has been sort of it's very it's tried very very few and far in between, like full on analytics to find out how fraud rings look and feel, and how fraud rings sort of carry on their business, right? So the benefits of this approach is, of course, enhanced collaboration with law enforcement. This goes without saying. So financial organizations often, as you might be aware, they collaborate with the local law enforcement or even with international law enforcement, and they help them to to nab criminals. And this sort of is valid across crime typologies, be it money laundering or terror financing or fraud and so on. So of course, the amount of information as a financial organization, or the amount of clarity that you can provide to your local law enforcement, that will be much higher if you are into this kind of analytics. Then, of course, improved forecasting. So, from a banking perspective, let's say what banks do is typically at the beginning of each year, they would try to forecast their fraud losses for the next year, so that that will be a part of the annual AOP. But again, fraud sort of works as a random variable, so it's very difficult to forecast. Most organizations would use something as simple as moving average and stuff, which again doesn't make too much of a sense. But if you've got a good grip of how the crime ecosystem is functioning, then you can sort of feed that information into your forecasting exercise and come up with more accurate numbers. Then, of course, you can have crime ring specific solutions. So, if you're able to identify that this particular fraud attack that you are seeing in your data right now has its root cause in this particular crime ring, say A, then of course you can use that information in your analysis, and that would help you to build targeted solutions. Then of course you have improved stability of counter fraud solutions. As I was mentioning earlier, the cat and mouse game that goes on leads to rapid deterioration of counter fraud models, right? Because as the fraudster maneuvers around your solution. But then again, if you understand metrics like the agility of the crime ring or the resourcefulness of the crime ring that is uh, targeting your organization, or so let's say that is leading to this fraud vector, you can again bake that information in and use that to build better models. Of course, you have targeted solution to disrupt crime rings. This again would be in conjunction with law enforcement. And then, of course, last but not the least, you can do a whole lot of interesting analysis on fraud rings, like let's say even creating a fear and greed kind of an index. So what that would mean is, let's say you've identified that over the past 2 years, there has been, let's say, 10 different fraud rings, right? That's there in your data set. Then again, you can isolate each of these fraud rings, and then you can create simple metrics like, all right, let's say fraud ring X has attempted, let's say, 100 fraud transactions, let's say, and out of those 100, let's say 10% of those transactions have failed, and let's say 90 of them have got approved. Then obviously it would mean that the fraud ring is emotionally is in a happy place, right? I mean, or in a greedy place, and the fraud ring would want to expand its ambit given the success in recent past, right? And that then again you might want to be extra cautious about fraud vectors that are emanating from those kind of fraud rings that have tasted success in the recent past. Similarly, the flip side to the story might be fear. So let's say if 90% of the transactions have been successfully declined or detected by your counter fraud solution, right? Or let's say law enforcement, let's say it's that particular ring is in the radar of law enforcement, then of course fear would creep in, and you might expect a decline in fraud attacks from that particular fraud ring, which again would help your organization to prioritize, when you are building your counter fraud solutions. So that's all from my end, and so the sort of the gist of the story is, um, just one second. Yeah, the gist of the story is, while it makes a lot of sense to continue with the way we've been conducting analysis, like which pivots around transactional fraud and which pivots around ID theft, or is trying to establish the ID of a consumer, it also makes a lot of sense to try out a third way of analytics, wherein we try to sort of think like a crime investigator, right? But instead of investigating one case at a time, we write a bunch of algos that can sort of automate the job for us and portray a very clear picture of how the criminal ecosystem is sort of behaving at this point of time. That's all from my side. Happy to take on questions.
Hey, thank you so much for for the knowledge. So there are few questions that are coming up. The first question is, can you tell about a few fraud controls your team would use to combat fraud?
Could you please repeat that?
Can you tell about a few fraud control
Yeah, I
your
saw that.
team would
Yeah,
use?
yeah, yeah.
Yeah.
So basically, the first kind of controls would be like dashboards to understand, where you are seeing an uptick in fraud. Like, let's say if you're a credit card company, let's say, right, you might be seeing an uptick at jewelry stores, or let's say jewelry stores in a particular country or in a particular state, or let's say some other kinds of MCCs, so different kinds of shops, right? So obviously, the first step would be to build a bunch of dashboards that tells you what kind of fraud is happening, where it is happening, if if it's happening at physical stores, if it's happening digitally, what kinds of shops are being impacted, and so on and so forth. And that obviously the next step would be to, once you glean insights from those kind of dashboards, to build rules. Like, you can use decision trees to build simple rules, or you can build machine learning models which would produce a score that can then help you to decide whether you want to approve or decline certain credit card applications, let's say, or certain transactions on a real-time basis. And the last bit of the story would be to build a mechanism that tracks all the solutions that you've deployed. Because again, as I have been mentioning, because of these game theoretic nature of fraud, fraud solutions are, I mean, they run the risk of deteriorating like really rapidly. So you would want to track their performance. And in case if you see that the performance of any solution is sort of deteriorating, you would want to push that, rebuilding that solution to right at the top of your priority list. So that's the spectrum.
Other question is, can we tailor the model to our unique business model, to a particular one?
Yeah, of course. I mean, you would have to tailor the model to your unique business needs, as in, the threat vectors that your particular organization is facing at this point of time. Because a generic model doesn't help anyone, and the reason for that is, um, your there are different kinds of modus operandi, like within fraud. And if you try to create a generic model, then these signals would get diluted in your data. So what would happen is, the score that you would be generating, it would be a very generic score. Like, I mean, what I'm suggesting over here is, if you're seeing that, let's say, a specific kind of fraud is what is troubling your organization, then it makes sense to build a full-fledged model for that specific kind of fraud. And obviously that would mean, using relevant features that can be mapped to that particular threat vector, and not sort of try to build a model that would take care of any kind of fraud that might crop up.
Okay, so that's all from the question sides. Thank you, Debanjan, for such a wonderful experience you have shared with us. So that will be all. There will be a 10 minutes break to our viewers. After 10 minutes, we will be resuming our event on the evolution of behavior for fraud detection. Thank you.
Thanks, everyone.